So let's continue. Question 16. Two wires equal length, aluminum and copper, have same resistance. Which of the two wires is lighter? Can explain why aluminum wire are preferred for overhead cable. Okay, data you can see resistivity and relative densities are given. So here we can use the formula R1 is equal to ρ1 L divided by A1, equal length and equal resistance, and that is equal to R2 is equal to ρ2L divided by A2. Now as R1 and R2 are equal, then we will get the ratio A1 by A2. A1 by A2 is equal to ρ1 by ρ2. Now next, mass we can calculate using the formula M1 is equal to A1. Density I am going to take here D1 to avoid confusion. And M2 is equal to A2L into density D2. Now we can take the ratio M1 by M2. M1 by M2 is equal to A1 D1 divided by A2 D2. Now A1 by A2 is ρ1 by ρ2. So substitute there ρ1 D1 divided by ρ2 D2. So calculate this ratio. We calculate this ratio. So here, all ones we have given for aluminium and twos we have given for copper. So see this ratio, when you calculate the ratio, you will get aluminium is much lighter than copper. That is why we prefer aluminium for overhead cables. Then question 17 is a graph question. So try to draw the graph and solve it. Now question 18. A steady current flows in a metallic conductor of non-uniform cross-section. Which of these quantities is constant? The question says already it is steady current, therefore current is constant. Current density, electric field, drift speed all depend on area. So current is the only answer. Then is Ohm's law universally applicable for all conducting elements? Answer is no. Then already the deviations from Ohm's law we have discussed in the chapter. If not, give examples of elements which do not obey Ohm's law. Gallium arsenide, semiconductor diode, all these examples we have seen in the theory part. Then next, part C, a low voltage supply from which one needs high currents must have very low internal resistance. Why? A low voltage, again formula I is equal to epsilon by R. If we need a high current, value of R should be small. Internal resistance should be small. Then next, part D. A high tension supply, high tension means high voltages, 6000 volt, must have very large internal resistance. Why? Again, we have to see this formula. I is equal to epsilon divided by R plus R. I is equal to epsilon divided by R plus R. And you know the case of short circuit, that's a very familiar term for you. Short circuit. And what is meant by short circuit? Short circuit means, the live wire and neutral wire will come in direct contact. So when the live wire and neutral wire, they are in direct contact due to some problem in the insulation, etc. At the point of contact, resistance R becomes zero. Usually, we know we connect some of the electric appliances between live wire and the neutral wire, and that particular device will provide the resistance. But now in direct contact, so what happens? Uh, the resistance R becomes zero. If R is equal, that situation we call the name short circuit. Then what happens? I is equal to epsilon by small r. So already the voltage is very high. So what happens? Very high current will pass through the circuit, destroying the entire circuit devices, wirings, everything. So if you want to limit the current, what is the option? Value of small r should be high. If value of small r is high, then the current will be less. So what is the purpose of having high internal resistance? The high internal resistance is required to reduce the current at the time of short circuit. To reduce the current at the time of short circuit. Then next, question 19. Choose the correct alternative. Alloys of metals usually have a greater resistivity compared to constituent metals. Then next, alloys usually have a lower temperature of coefficients. Alpha value is small for alloys, that also we have seen. Next, resistivity of an alloy resistivity is nearly independent of temperature. Then resistivity of a typical insulator will be very high in the order of 10 power 22. Then next, question 20. Given n resistors, each of resistance R, how will you combine them to get a maximum resistance? So resistance will be maximum when resistors are connected in series. So R max will be n resistors connected in series, so value will be NR. Then minimum means you will get the minimum value when all resistors are connected parallel. So value will be R by N. You have to take a 1 by Rp is equal to 1 by R1 plus 1 by R like that. So N times. Take the reciprocal, you will get R minimum is equal to R by N when all are in parallel. Then what is the ratio of maximum to minimum? R max divided by R minimum you have to take. That ratio R max divided by R minimum, you will get the answer N square. Then next, part B, given the resistors 1, 2 and 3, how will you connect them to get these resistors? Okay, so here first of all you can see which value is less than all the resistance values, that may be the parallel combination. So you need to check all series, all parallel, then two of them series and the third one parallel. So here also you can interchange the positions. Around 3 cases you will get. So next case we can take like this, two of them parallel like this and the third one series. So here also you can interchange the positions of each one. So you will get around 3 cases. So 3 plus 3, 6 plus all series and all parallel, 8 cases you have to verify there. Okay, so verify those 8 cases, then you will get the answer. So see here, first case, if you see, first case is like this, 1 ohm and 2 ohm are connected parallel and 3 ohm connected series. Second case, you can see 2 and 3 are parallel and 1 is in series. Third case, you can see all of them series, and fourth case, all of them parallel. Next, here, part C, determine the equivalent resistance of the network shown there. Okay, so here you can see these units are connected series, these units. So you can calculate the resistance of each unit. So first unit you will take upper part 1 and 1 series, so you will get 2. Lower part 2 and 2 series, you will get 4. So that you will get 2 and 4 ohm. Total 2 ohm here, total 4 ohm here. 2 and 4 connected parallel. So as 2 and 4 connected parallel, you can calculate the value of that parallel combination. So you will get around 4 by 3 there. 4 by 3 each unit. Now such 4 units are connected in series. So into 4, you will get a 16 by 3 is the effective resistance. Now here you can see all of them connected in series. So you have 6R is the total resistance. 6R. Okay, now next question 21. In question 21, determine the current drawn from 12 volt supply with internal resistance 0.5. EMF is given, internal resistance is given. External resistance we need to calculate. First of all, everyone should understand this is an infinite series. So in this infinite series, I'm going to remove the first unit. First unit is removed. Now you see, take, so I give the name here, point A and B. Now the total resistance of the combination, I will mark as X, the total resistance of the combination. Afterwards, the first unit is removed. First unit means how many resistors? 3 resistors. These 3 1 ohm resistors are removed. Being an infinity unit, even though 1 unit is removed, that cannot make any difference. Therefore, the remaining network also will have a resistance X, I can say. So first of all, we take the total resistance of the infinite network is X. Then first unit is removed. The remaining unit from infinity, if you remove 1 unit, cannot make any difference. So remaining unit also will have the resistance X. Now this resistance X, how it is connected? It is connected across AB. This X is connected across AB. So that I will draw an equivalent circuit now. So here first unit, each of 1 ohm, and the remaining part having total resistance X is connected between AB, which I will draw as a single resistance now, whose value is X, and the effective resistance between these two terminals, that also X. That means the total network. Now you will get the equivalent circuit. From the equivalent circuit, you can first calculate effective resistance of this part. X and 1 ohm, this 1 ohm AB are parallel. So effective value you can calculate like this. The total resistance here we take as R dash. So 1 by R dash is equal to 1 plus 1 by X, or R dash is equal to X divided by 1 plus X. Take LCM and take reciprocal. Now this R dash and this 1 ohm and the 1 ohm of the bottom, they are in series. Therefore, the total resistance is how much? X. X is equal to 1 plus R dash. R dash means X divided by 1 plus X plus 1. So this is the total resistance. Now take LCM there, simplify, construct a quadratic equation. You will get X square minus 2X minus 2 equal to 0. Then take the positive root of this equation and find the value of X. Then you will get the effective resistance of the network. Once you get the effective resistance of the network, you can calculate the current. I is equal to epsilon divided by R plus R, where R is equal to X, the total resistance of the circuit.